Your 2-day task keeps taking 2 months. Here's Tim Ottinger's fix. If you push big changes and wait for the grand reveal, you pile up risk. Tim shows you how to slice smaller so you deliver value faster. You'll learn the best engineering practices Tim has found to expose risk early, get feedback sooner, and ship predictably. Tim walks you through why front-loading testing, cutting WIP, mapping your value stream to find cues, and using pairing will shrink time to actual value. You'll see why tiny releases beat big batches every day. Watch through and you'll leave with Tim's approach to turn steady weekly wins into experiences and games players love. Let's get you shipping faster. We have so much more code being written than has ever been written in history. Are we good at this yet?
There are places that are abysmally behind, that are roughly, starting to charge boldly into the 1980s. And then there are others that are well ahead of the curve. And it's really a difficult environment because if you're working in a place that is, circa 1995, it's hard to believe when you hear people talking about their 2025 world, especially when everybody believes they're in a 2025 world. Most engineering managers have zero training. If they do have it, they were promoted into engineering management before they were trained. Most places treat programmers as if they are finished products, that they should already know everything that they're going to need to know for the next 20 years of their career. And if not, then they should probably be studying on their own time, borrow that from their wife and kids, right?
Right.
So you shouldn't not know something. And so it's kind of a weird world. You've got a BS detector, right? When somebody's lying to you, you pretty much know it, unless they're really good at it, right? And you can tell because the things they say go into your ears and it's compared. And is that what they said consistent with my experience? Right? If you studied science and you've done some scientific experiments, you've done the math, then things that don't seem to match up with the laws of physics, you're going to be pretty hesitant to accept, right? If you have lived in a community of engineers for a long time and people have ideas that are not engineeringly possible, that's going to smell funny to you. But your BS detector is based on what is consistent with your experience so far.
Right.
This makes it hard to understand and accept any ideas that you haven't seen before. Right? So, an example of that is somebody was working with reform of people who had been criminals, right? And when they talked to them about not stealing, what they imagined was the life they have now, but without having any stuff in it. They don't get any stuff. So they are a criminal living in the underbelly. Nobody will employ them. Nobody trusts them. Nobody cares about them. But they don't even get the PlayStation when it comes out. They don't even have that bright spot anymore. It's all gone. We talked about drug users. They see the life of a drug user, but without the momentary highs, right?
Right.
Well, that's because you're comparing it to your experience. The idea that you have a different kind of life as a non-thief, that you can hold down a job and that people can trust you and you can have friendships and that you're not on the run from the police. You're not even nervous when the police come by. As a non-drug user, you're not having to deal with the people you had to deal with before, and you're not having to deal with the problems you had before. It's a different kind of life. So if you're a developer and all you've ever seen is somebody hands you an assignment, it's your job to code it up as fast as possible, turn that ticket around, and go into the next ticket, and they're going to be measuring how many tickets you do per fortnight or some other nonsense like that.
Right.
If that's what you've been seeing your whole life, then the idea of people who get together and they're self-organizing around the tasks and they get things done in days instead of weeks and they release, 12 times a day or 20 times a day, that sounds like Star Trek.
Yeah. One of the most common ones I see is I'm often trying to push teams to shorter cycles. And one of the things that always happens is like, hey, based on the amount of change in your environment, you're right now running 2-week or month-long or 3-week, sort of release cycles. I think if you did a week, it would better match the amount of change in your system. And they go, what are you talking? There's no way we could do, and because they think, well, what are all the meetings and the difficulty of the integration at the end of 3 weeks or a month or whatever, like all of that, doing that every week? We already spend most of the last week just doing integration. Like, we would never get anything done. And it's exactly what you're saying. It's this idea of how could I possibly have that, a whole day of planning and I'm doing 1 week cycles. Like, well, if you do 1 week cycles, you don't need a whole day of planning and you don't need 4 days
That's right.
of integration and testing at the end. All those things get shortened, but you don't know that.
This is one of the problems that happened in the late 90s when people started coming up with the whole evolutionary design and incremental development. Well, okay, incremental iterative development goes back to the 50s, but it was pretty underground through the 80s, and in the 90s, late 90s, it resurfaced and people think more about it these days. But everybody knew that you released once about 18 months. So that's all you could possibly stand. And the last 3 months before a release is integration and bug fix. And you've got to have that. And then some crazy people came out and said, oh, but you should release, from, a few weeks to a month. And it's like, well, no, because it takes 3 months to get ready for a release. And they didn't realize that when you release a week's worth of work, it's a tiny, tiny change set. There's only so many things that could be wrong, right? And if you release once a year, then it's all the accumulated change sets that haven't been tested yet. And it's a big problem. So the size of your change set is pretty positively correlated with the risk of release. If you want to release 250,000 lines of code a month, more power to you, brother. I don't want to be there for it. That is too terrifying for me. But you're right. If it's a 2-week thing, you do 2 weeks worth of work, and then you have to go through all the, all of the overhead. But if it's a 1 week release, you have roughly half as much going on, maybe a little less than half. And it's a much smaller risk. So you're more likely to release. And if you're releasing several times a day, each release may be 2 lines of code, 2-3 lines of code. And the risk is really small. And the testing doesn't have to be, quite at the same level. You can run a lot of automated tests in a few seconds now, that we couldn't do before.
Yeah.
So the shorter cycles are hard to imagine. Things like this are important. You just can't see them. And when we talk about working in groups, everybody imagines that one project, college or high school, that they forced 5 of you to work together, but one of you had this psych project that they had to work on, and there's a lot of number crunching, so they really couldn't participate. They were too busy with their other project somewhere else, and you never saw them until the day you handed it in, and their name was on the, they got the same grade you did. And then you got the other person who just didn't understand what they were doing at all and made a mess of it. And you had to redo all their work, but their name was there too. They got the same grade you did. And you see, I carried, the 2 of us had to carry a team of 5, kicking and screaming in to get a B when we easily could have gotten an A+ on our own. And it's all the people held us back and they didn't participate and they just caused trouble and asked stupid questions. And that's what collaboration is, because that's consistent with my experience.
Yep.
Have they ever worked with a group of people who were really keen on, have you ever been on a sports team? Have you ever gone, spelunking or, abseiling or anything where it's cooperative and you're all like keen on it? That's a whole different story. Well, what happens when, we have a UI and a UX and a back-end developer and a front-end developer who and then somebody who really is good at styling this stuff up, and we've got, a tester on the team, and we're all really keen on getting this thing done, and we're not drawn out because we have our own work to do elsewhere. What happens there? Well, you talk about collaborations and people can only imagine, they're going to sit and watch me work, and then they're going to get the same grade I get.
Right. Yeah. Well, so you just named one big reason, because I had a question. It's just like, why do so many organizations struggle? So one is so many organizations contain people who don't know what better might look like, because like you said, their BS detectors kind of go off at the wrong time. What do you mean? Like, simple one, there's a guy named Richard Hensley. He did a lot of work in sort of lean environments, and he ended up being an architect and a director of engineering, and he actually got to run some numbers of paired programming against non-paired programming as a total output. And he said, you were, depending on how you measure it, right? If you're just looking at lines of code, pairing is less efficient. If you're looking at amount of time it takes to actually produce stable value, paired programming vastly outperformed individuals coding on their own, even with code review. It wasn't you're just out in the wild. It was, there were still best practices, trunk-based development, as far as I know. He was doing code reviews and things like that between engineers. But he was paired programming just blew them out of the water because the time to fix was so much shorter. And as time to fix increases, so you got a good resource here. Paired Programming Illuminated. Who's the author of that one?
So this is Laurie Williams and Robert Kessler. Laurie Williams is a researcher at the university. They did double-blind studies. For many years, pair programming was the only one of the XP practices scientifically proven to work. So my developer writes some code. They're quick. They turn it around really fast. They pass it on for code review. And the code reviewer says, no, that's not it. Sends it back. Is that when they fixed that, have we lost 15% of the time? Probably more than that.
Yeah.
We may have already doubled it. Okay, well, it goes through the code review and then it goes to a separate testing department. What happens when they reject it?
Right.
Well, it goes back. They have to do it again and then has to go through code review again. Now we're taking multiple people's time in effect, right? And so they get from that person, then they goes on and they do the security scanning later on. There's an automated scan and nope, this has got some issues that need to be resolved. It goes back to the developer, who, by the way, is 3 jobs down the road, and it's an interruption. So now 3 things have been pushed back to get this pushed to the front of the queue. They resolve the problems. Where's it go? Does it go to the end? No, it goes to the code reviewer again.
Right.
Code reviewer goes to the tester goes to the security. Then we're going to go through the final tests before we put it out there, some kind of play testing, and somebody doesn't like it. All the way back again, all the intermediate stages. So we have these loops, these nested loops of things.
Yep.
Okay, what happens when I have an error? Does it cost me time or does it not cost me time? Well, I still turn the ticket around. That's a separate ticket. It doesn't matter. Well, doesn't it? You're measuring your capacitor and you're ignoring the trace, right?
Yeah. Yep.
Measure end to end on the trace and you'll find out that your error is costing you 12x, 14x the time you put into it initially. Okay. How much would that have been reduced if we pair program? Would it have eliminated all round trips? Well, probably not.
Right.
How much would it have cut it down? 40, 50%.
Yeah.
Wow.
Right.
40% fewer round trips? You're delivering 4 times faster. That's amazing. But to do that, you have to have more focus at the point of code creation. And I think this is the thing that people miss is they think that the programmers, they need to type faster and turn it around quick.
Yes.
But really, if the programmers are given the resources they need, whether that's other programmers, whether it's code checkers, whether it's a great IDE, whether it's an LLM, all the things you can do so that the code is really well considered and well checked out and well reviewed before it's ever pushed on down the road.
Yeah.
You could put triple the time into programming if you got 50% better first time through ratio.
Yep. It'd be well worth it.
And boy, you'd be so far ahead. But everybody seems to want to know the programmers have to type faster. I know.
Yeah.
Why don't we have them stay over and do 18-hour days? That'll get a lot more typed. How many more programmers do you make how many program errors do you make on your 12th hour compared to your 3rd hour or your 8th?
Is that a studied thing? I'm curious.
It has been studied. I don't actually have the numbers handy, but they're finding that somewhere around 3 or 4 hours of extra work often will cost you a day.
Wow. Just an errors generated.
Yeah.
Yeah. Does this sound familiar? You're in a leadership role at a game studio. Everyone is busy working. No one has any time. But the actual game itself isn't in a good spot. Maybe it's the tech. Maybe it's the lack of a validated prototype. Maybe it's that every person seems to have a different idea about what we're trying to build. But you've got a job. There are reports to send, meetings to schedule and facilitate, the occasional season of performance reviews to go through. And everyone is always so busy. When you step back, it makes you wonder if everyone is just going to keep slowly walking towards the abyss until the project or game fails. Is this what it means to be a leader in games? In tech? To endlessly repeat the same sequence of meetings without really moving the needle? To spend hours trying to get Jira tickets and dashboards where they should be? To pretend that everything is fine when you know deep down it really isn't? It doesn't have to be this way. You can make a difference. You can help your team and game succeed, but sometimes you need a bit of help to get there. I've started a game dev leadership accelerator. It aims to level up leaders who see opportunities to make a difference but don't know how to capitalize on them. We'll walk through what it means to lead well and give you tools to understand your organization's challenges and implement changes to overcome them. Game dev is hard. Knowing how to lead will give you an edge. It will still be hard, but you'll be ready to tackle it. If you're interested, let me know below. Hit the link. I hope to see you in the accelerator because I believe better leaders will help teams make better games, and I look forward to someday playing what you create.
Yeah,
by the way, this matches my experience. I got to study this for a group of a very cross-disciplinary group. They really wanted to do a 2-week crunch at the end of a project we were doing, and I didn't want them to do it, but they were like, no, we're going to do it. We're all in gung-ho. We're going to get this done. I got to measure what was the output of the extra, of the hard crunch that they did, because they all came in early and I got them food and, it was like they're there all day, but I didn't allow them to do more than 2 weeks. They got no more work done in those 2 weeks than in any other 2 weeks, but they were there a lot longer. And I also, part of me was like, hey, look, at a human level, we'd been working on this project for a very long time. We were about to ship it. Part of this was actually just like a team, coming together and being excited together about this thing. And they were like, we're going to push hard because that's what we do. But it was honestly more almost about the social reality. And so I wasn't offended by it in the end, but it was noteworthy to me that it was just like, this didn't, you all thought oh, that's how we're going to get it all done at the end. It was like, we didn't actually need this. We could have just kept working normally. You could have kept going home for dinner with your families. But I get it, right? You were all excited, and they were. It was actually a very high morale team. It was really exciting to get that thing over the line, and people weren't mad. And I told everybody, you don't have to crunch. If you want to, I'll be making sure you're taken care of. But it's okay.
Yeah.
And so anyway, for me, that was the one time. That's again, it's anecdata, but that was my data point of I don't think this is as effective as people think. And you're actually saying no, actually, it might be inversely correlated with success.
But you have to again measure the trace and not just the capacitor, right?
Right, because tickets. If we measure someone, if we suboptimize into the idea of a ticket moving to done, means that we're succeeding. Then Eliyahu Goldratt, tell me how you measure me, I'll tell you how I'll behave. We're going to get a lot of tickets through the system. It's just like when people tried using lines of code as a measure of engineering efficiency. We got a lot of lines of code.
So how much more performant did they feel that they were in crunch week compared to how much
they thought they were? They thought this was it. This is when we really,
really made it happen.
Dug in and we got all the things done that we needed to do. And again, I wasn't I wasn't going out there broadcasting. Nope, it wasn't affected, but because I was just whatever, it's fine. I have a set of data. You could probably even nitpick at my data, right? Was it the right data? Was that a good way to track progress or whatnot? But it was just they felt like it was really important. And again, I think actually from a social angle, I could actually buy the argument that it was important for them to feel like they'd done a good job based on their norms from the past of being game developers. To have not crunched at all would have to them felt like a failing state, even if it wasn't necessary. And so they had to. And so for me, the fact that I got to only do it 2 weeks, that was a win for me.
And that's a ritual space too, right? One of my early mentors referred to it as amateur theater. And I didn't understand. He said, "Oh yeah, well, if you're involved with civic theater, amateur theater, everybody, we pick out, we're going to do this play. And everybody's like, oh, that's going to be great. I'd like to do this play. And they try out for the different parts and they get excited about it. And they're talking about their designs for costumes and sets and how they're going to do this thing. And weeks go on and they start to have a rehearsal and nobody's learned their lines. And then they go a few more weeks and it's like, well, a couple people have learned some of their lines at least. And the songs, the musicians don't know how to play that out of the pit. And, it's everybody has jobs and families and, the weekends they're watching the kids' bowl games. They're not, running lines. And you get towards the end and the last week before opening night, they realize we are in such trouble. So they all cancel everything and they're spending every waking moment running lines. It's like the montage you see, on so many of those shows. And they're practicing the songs till they're hoarse, which that's a dubious practice. They're staying up building the sets. They're sewing the costumes, and finally it all comes together. And on opening night, they're terrified, but the curtain comes up. They make it through the performance. People stand and cheer. They've got 3 more nights to go. They're all excited. They have a big party. Hey, we did it. We did it. We did it. And then when it's finally all over and they pack away all the stuff and get rid of all the costumes, and then they start talking, it's like, we should do this other one. And the same thing repeats. It's always 90% of the work done in the week of opening night. And they do this year in, year out for ages and have since the beginning of time. Well, we sometimes see something like that, right?
Oh, yeah.
Because steady states are hard. Events are easier.
Yes.
And would you still feel like you were productive if you were producing, wonderful results every week? And if a release was no big deal?
Right.
A release was just another Tuesday,
Yep. I think this actually comes to look at the idea of the people that go from a big release at some longer cadence versus the small ones. There's a psychological desire almost for that big moment. Right? I mean, we experience this in game dev. We talk a lot about the grand reveal. I try to push people away from the grand reveal. We don't want to be doing the grand reveal because the grand reveal in a space where most games fail is an opportunity to reveal something, have it fall flat. But what everybody has in their mind is I grand reveal and every player out there is just super excited and they just love it and everybody jumps in to play it. And now we're all, well regarded reputationally and millionaires because of the shared, profit and blah, blah, like all this, we're all, and the problem is if I tell that team, no, let's like just do it until it's really not very good and then put it in front of people and see what they think.
See if we're in the right direction. Yeah.
See if we're in the right direction and then keep doing that. There's like this, but I want to only show my good work. I only want to show it when it's all ready. I only want to show it when it's done. And there's little mini versions of that. That's an extreme version that fortunately we don't do as much anymore. But that was the way you develop games was like, no, you didn't have a good, you just dropped it. And it was like, here's the game. It's gold mastered and, it's on CDs or in cartridges or whatever. Like, here you go. And nowadays you do see more, but you still see little versions of it. The artist or the engineer who wants to get that thing really buttoned up before it goes out. And again, psychologically, you can understand why. It feels really good to show something and have everybody be like, wow, that's amazing. That is so, versus like, all right, here's this thing. It doesn't really work right. A bunch of it's totally temp. Is this the direction you want to go? And go like, I can squint. I can see that. I think that's fine. And I can, I have empathy for the person who's like, I want the big release. I want the big moment. And simultaneously, it's just a terrible way to increase your odds of succeeding in the long term.
Yeah. There's a lot of people who are afraid of even early feedback because what if the early feedback is that you have a dumb idea?
I know, but
what if you need to cancel your game because it's just a bad idea and nobody wants it?
What if you need to pivot right at the beginning?
Yeah, what would you do then?
When would you want to know? When do you want to know you have a bad idea? And I think that's actually the conflict between the emotional side of the developer and the intellectual side. Because if you ask them the intellectual question, when would you want to know this was not going to work? Most of them would say, as soon as possible. Like, I want to know right away. But the emotion, and this, I do not believe we're rational beings who have emotions. I believe we're emotional beings who are occasionally capable of reason. Yeah. Or that is we just rationalize our emotions. But I think that idea that the emotion often wins there Even though the intellectual part of us knows, like, I would rather know in a week or 2 weeks or a month or whatever, as fast as I can, that this isn't a good idea. We need to go in a different direction. But I don't want to know that at a very deep level because I'm excited by the idea and I think it's cool.
And I feel like it's right to be devoted and committed to this thing. And
that's right.
We often have managers like, we need you to be devoted and committed. We need you to drink that Kool-Aid. We want you to be totally on board with this thing and put everything you've got into it. And what if we find out, like, 2 days in that this 3D artwork is actually completely in the way? They would rather have a cheap 2D rendering and all this work to get the black outlines out. They want the black lines. They like the black outlines. It's a style, and what if all this work we've done on the, this clever background art, what if that's just junk? What if that was completely unnecessary physics work that we could have done away with? Would a simpler game have been better? Would a prettier, dumber game have been better, or a smarter, uglier game been better if we had to make choices? And the engineering side, it's still the same question. Like, I'm writing something. When do I want to know that what I'm writing isn't going to cut the muster, right? Well, and again, our idea way back when was focus on the time that you're creating the code, right? That's when you need all of the talents and all of the disciplines focused in one place, right? If we can get it built well, then we move on. Well, that doesn't necessarily mean that we have exactly the right final code as it comes off our fingertips, because nobody can do that. There's something that makes sense today, and then we find it doesn't perform, or it's not secure, or it's got some little problem. So we want to make sure that the code, as we write it, at least we'll be able to understand it and spot problems quickly. So we won't make so many mistakes. Well, if I write code the way I like it, and you write code the way you like it, who is going to be the best one to look at your code? Well, you are. You're the author. Well, why didn't you and I both write to the joint audience? Right? Why, if our audience speaks Japanese, why are we doing this in English? Kind of thing. So from the beginning, why didn't we write the code we all knew? Well, because I was working alone. So maybe, I really know the programming language as well, but I don't know the Unity framework as well. So I'm working by myself. So what do I know? How much of the total game framework? Well, I know a little bit about how to use the physics engines. I know a little bit of this and a little bit of this UI. How much do you understand about that? Well, so much. Do you know 85% of your game's software by heart? Well, of course not. If it's a big game, 3%, 5%. If it's a small game, you might know 30% of it, really have it internalized in all the structures. So I'm working with what little knowledge I have of my language and framework and stack and operating system and deployment mechanism and, all these things. And so I'm going to work around things I don't know in order to get them done quicker. And I'm going to write the code in the way that I think is best because I'm alone. And because I work alone, when I put my code in, that it's going to have my foibles in it. It's going to have my flaws. Right. So of course you're going to inspect it. So what we're going to do is we're going to make something that's maybe not very good, and we're going to start passing it through quality gates to try to filter out the badness of it, right? Because really, most of us have a process whose purpose is to prevent software release. You probably do too.
Yes.
Because the assumption is somebody's going to make a bad change and we have to stop it from getting production. So we build everything to stop release, prevent it. Okay. And people work alone, and we give them all individual assignments, and they work by themselves with whatever knowledge is in their head. So we have to inspect, we have to retest, and because any of them may be making mistakes. And I guarantee you, your senior person makes mistakes too. It's not a junior versus senior. They just make different kinds of mistakes.
Yep.
So we're building this big pile of it. So we're going to burn the toast and then scrape it until we can deliver it to a customer, right? It's not a real smart way of working. It's really not. And we've talked about those nested loops and inspections. If you have code inspections, should 100% of the stuff passed off for code inspection be passed through the system without change, or should some of it be returned?
If you have it, it's probably because some of it should be returned.
What's a good percentage for that? I think returning 15% is pretty good. 85% passes.
I mean, my mind as a more of the process guy. It's like as low as possible.
Well, it's kind of funny because,
but yeah, you're gonna figure that out inside of your context.
Yeah,
it probably
so-
depends on a ton of things.
so if you had 10 quality gates and each one had 90% pass rate, then the code that you submit only has a 36% chance of making it through the system. That's not very good.
Yeah.
You probably have a whole bunch of things in process that are bouncing back and forth between stations, or going forward, bouncing back and repeating
Right.
and repeating and repeating, because it's the product of the pass rates is the pass rate of your pipeline.
Yep.
So 0.9 times 0.9 times 0.9.
Yeah. Well, and you also get the issue of, we've talked a lot, I think, at least in the last 10, maybe 20 years about the state of flow for engineers.
Yes.
How important that is, because it's not task work, because there is science and art, that is actually the bulk of what is hard about engineering.
It's applied
And
science.
the idea of, it's you come in and I interrupt you because something you coded 2 weeks ago that just reached gate number 8 has come back and needs attention. And so it only reached you after it went back to the product manager, because gate number 8 is pretty far along. And so like it hit a quiet, and then it hit tech lead, and now it's back to you, and they're going like, and you've been working on other things for 2 weeks, and you're going, what, the hilarious thing is how often you can show an engineer their own code from 6 months ago, and they'll be like, what was this idiot doing?
Yeah.
But I think there's a reality there that also speaks just how rapidly people learn, and how often we've moved on. We don't even recognize this. And so now I'm having to like go out of whatever I was doing. Spend some
travel
time.
back to when you wrote the original code.
What was I thinking, right? Like, and now I have new data, so maybe I would do this differently. Like, do I just completely rework it? Do I just fix the little issue and send it forward? Maybe that depends on how you measure me, right? Like, maybe I just like, if you're measuring how many tickets I get through and that's how I get promoted or a raise or something, I probably do the minimum thing to like, okay, maybe this time it'll go all the way through.
Is each bug a separate ticket, or is it the same ticket coming back? Because if it's a separate ticket, I can turn over 25 tickets with one change.
That's right. There you go. Yes. Yeah. And I think this, the cost of this, I talk a lot about, especially recently, I've been talking a lot about estimation, and I made a course around estimation. And there's this idea that the further out something is from us, the harder it is for us to learn from it. Like when I make a decision,
of uncertainty. Yeah.
Yeah. When I make a decision, if I have an outcome from that decision that's, weeks out, it's hard for me to learn the lessons from that decision because I'm not there. Whereas if I get immediate feedback on my decision, it's very easy for me to learn. If you only if you had a dog and you were training a dog, and you only ever punished the dog 4 hours after it made the mistake.
Yeah, it's not going to associate it.
It's never going to learn anything, right? It's never going to, and we like to think we're so much better than this. We're really not. We're a little bit better, but we're not that much better than this. And so the more immediate you can make the feedback, you just shot a link.
Oh yeah, I shot you a link. It's to an article called Faster and More Predictable that I think you'll appreciate. And it's about flow. And it covers some of the same things we've been talking about. Nice. So I'll leave that for you for later if you want to attach that or not. And it shows some nested loops and talks about some of the issues and situations. So when you talk about, if we could write code that had a 94% chance of making it through, that's going to be interesting because it's going to be hard to justify the cost of the code review. And it's going to be hard to justify the testing department. It's going to be hard to justify. But hold on, if we really are going for quality with a short lead time, if that's really important to us, then it's like, well, let's focus on how can I get code written that's 94% likely to pass through all the quality gates. And you're going to hear a bunch of people, the BS detectors are firing right now. I can hear all the alarm bells going off and the buzzers. It's like, well, you can yell at me to write better code and it won't help. If you put more pressure on me, it won't work. And that's right. They're right. All of those things are true. Those are not techniques. Motivational techniques will not change this, right? We are human beings. Programming is largely intuitive. We load up our brains and, all that pattern matching hindbrain magic that's so incredibly powerful. We load that up with all of these different patterns, and we sit down, we look at a problem, and our brain spits a couple patterns out to us. How about if we did it this way? How about if we did it that way? And of course, the prefrontal cortex gets hold of that and says, that one looks really promising. Let's try that one. Right. And we start to type the code, and it really is intuitive. It's almost muscle memory. We're almost just feeling the code going, the variables flowing through the algorithms and out the other side. I don't know what your, what do they call that? Synesthesia?
Oh, yeah.
I don't know what your synesthesia is. I mean, some people, all they think about with code is literally punctuation on the screen. I found out. I thought that was really weird. But a lot of people see shapes or colors or movement or flow. They kind of feel like it's in places and things are connecting to places like a circuit would be, or like a machine. They feel that as they're typing the code, and their intuition is engaged and they produce the thing, right? Well, that intuition isn't focused on all the problems. It's focused on implementing this idea that's probably going to solve the problem and evaluating that. And because it's intuitive, we're in an interesting state. You mentioned, that things that have our name on them that have been passed into the quality gates, they have our name on them. That's an invitation to interruption. Every single thing that's in the pipeline that has our name associated with it is an invitation for an interruption. The more things I'm involved in, you see this, this as a manager.
Oh, yeah.
You're involved in everything, and everything comes to your desk, and you're constantly interrupted. Well, here's a developer trying to focus, and they have to have enough room for their intuition to bloom and for them to move forward. And these interruptions come in because these things are partially done. They're in flight and they return. Okay. How can we do this 94% miracle, right? Well, my intuition alone isn't enough because I have good days and bad days, good hours, bad hours, right? I'm going to need more. I have to be augmented. You can help me by giving me good plugins and IDEs, right? So I can look up in the corner and see the warning mark in the corner. Well, if I never act on that warning mark, it's done nothing for me. My chances of passing through are no better than they were. And there's squiggly red lines in the middle of code and in the right gutter. If I don't pay attention to those, if I ignore them, they don't help. If I don't run the compiler periodically to see what doesn't compile, it's not helping me much. If I don't run the linter while I'm developing the code, if that's just a step that happens 5 days after I commit, I don't have any assurance I'm going to pass those rules, right? If I don't have tests that I'm running at my workstation, I don't have any assurance I'm going to pass the test 6 stations down the road, right? If I don't have that intelligence, what about the UX? When is the UX person going to, look at the experience of using this? When is the UI person going to look at look at this? When's the graphic artist going to look at this? Well, they gave me assets. They're done. It's all up to me. Well, what if I make a misstep? Well, then they're probably going to reject it again. That's going to be one more thing with my name on it that's going to come back to me. What if we could gather the people? If pair programming is a 40% reduction in errors, right away, that's going to take us closer to our 94. What if our testers are with us and they say, how I'm going to test it? I'm going to check it for this and that and the other. And we go, let me write an automated test for that. Like this? And they say, yeah, like that. Okay. Oh, it doesn't pass. Let me fix that so it passes. And I'm going to test for this too. Oh, yeah. Type, right? So we're working together as it rolls off my desk. By the time I commit and push, any error that happened before that point never happened. It's invisible. It doesn't exist.
Yep.
But say I did take twice as long, but I managed the 94%. You're going to be releasing all the time. You're going to have great stuff going out the door. Yeah, and you may still catch something here and there that none of us thought about. But the idea of working in a group has a curb appeal problem that we remember that time in high school or college.
Right.
So we need to have a good experience so we learn how to release our intuition even when we have people around us, virtually.
Yeah.
And that's a hard thing to sell because most people, if I don't work in the way I'm comfortable with the formatting I like, with the shape I like, I don't know how to release my intuition. It clogs. It shuts down on me in a group. So I have to learn to do that, and I have to have good experiences so that I can look forward to doing that.
Well, I think that, and that speaks to that idea of discomfort. But the other thing that's coming to my mind for some reason is the idea of an andon cord in a production environment. And because I think some people go, look, this just isn't how code works. And I go, this is how this is how things are done, because an andon cord in a production environment is anybody on the line doing very much task work actually in that environment. If they see a problem, they are supposed to pull a cord, which stops everything. And this was so unintuitive to Western manufacturing, particularly American manufacturing. But Japan was just kicking our butts when it came to this. And it was because if every time I see an error, I stop everything until I know how to solve that error and potentially solve it in perpetuity, then I'm going to, over time, have so many fewer errors that I will never have to stop the line, versus a world where the individual is pressured to, I have to try to solve the error as best I can here. And if I can't, then it will get caught in a quality check. Who knows how far down the line, when a bunch of other work has been done to this thing that is now going to have to be undone. And that thing is going to be returned, and we're going to discard it as waste potentially. Or if we can, we'll send it back to a much earlier stage, and it's going to come back through that system. And you think that, like, well, it doesn't matter, there's not that many errors, but this is where so much study has been done on this in so many different fields, that like the impact of small errors inside of these systems that get caught later only grows. And so what you're describing is this idea, this like mental model that is, if I can pull back all error detection to as close to when the engineer is implementing as possible, so that we hit that 94% point you're talking about, where like, hey, we've got a 94% chance of going through all the gates. Not a 36, a 94, right? So that, again, now we're questioning, are the gates worthwhile? Which is, they probably still are, but that's a separate thing. But like, we now have confidence, and this allows us to be confident in everything we're doing. And that delta in like, we're confident in everything we're doing versus we're not, is just, it's insane. And I can say, again, it's not just engineering. This applies to so many other areas of life, and work and in industry. But yes, to your point, we're not used to it, because in the space of knowledge work, it is often collaboratively done. It has to be, because one person can only do so much.
That's right.
Sorry, you got me on a rant there.
That's okay. That's a good rant. Where did you grow up, by the way?
I grew up in rural upstate New York.
Okay. So you'll get this. I grew up around, Indiana, Illinois. So northern people still. It snows. Yeah. And so it was snowing, and I went outside with my little plastic shovel. I have a plastic shovel because it's light. It's easy to move with. And I go out, and there's 2 inches of snow down, and I clear the driveway. And a little while later, there's 2 inches of snow down. I go out and I clear the driveway. And a little later, there's 2 or 3 inches. I go out and clear the driveway. Stay up kind of late doing it. And my son was living with us at the time still. And I said, hey, grab a shovel, let's go. And we're going out to it. And then we do it again. And then we do it again. And he's like, Dad, why don't we just wait till it's done snowing and then get it all at once?
Oh my gosh. Yeah.
So living in a place where you get sometimes a meter or a few meters of snow overnight, you know how hard it is to clear a meter of snow.
Yeah.
That is not a comparable job. You can go out dozens of times and move 2 inches of snow. It's such a breeze, 15 minutes and you're back inside drinking cocoa. But when you have a meter, 3 feet or 6 feet of snow, that's an all-day job. And, so I told him, well, we do it when it's easy, so we don't have to do it when it's hard. If you do it when it's easy, you don't have to do it when it's hard. And it's like, why do I have to do dishes? We just ate. All we've got is, because right now it's easy, but if you leave them overnight, it gets hard. Stuff dries on. It becomes difficult to remove. I don't always clear the supper dishes right afterwards, but I know that this rule applies because it bites me when I don't.
Yes.
So you do it when it's easy, so you don't have to do it when it's hard. That's pretty key here. It's not just shoveling snow. It's all the things we do. Removing the bugs when it's easy is so much better than taking them out when it's hard. And refactoring the design as we're adding features while it's still early, so much easier than letting the code become a nightmare and then trying to inflict quality through refactoring, right? Getting the tests in right away as opposed to waiting till release day and then writing a bunch of tests. So much easier. Do it when it's easy so you don't have to do it when it's hard.
Right. You and I both have, I think, the same experience, which is most people are probably at an org that is not in a healthy state. And that means a bunch of different things. Again, it could just be like everybody's got bad norms. It's very hard to shift culture, to shift experience. You've also worked with organizations and tried to help get them on a better track when they were on a worse one. What would you recommend to the leaders in game development that are out there that are listening to this and are going like, shoot, we do a lot of waiting for all the snow to dump and then get wet and heavy and break our plastic shovels. I wonder what it would look like to clear every hour or two so we don't have that issue. What should they do? Where do you start with this if you're in the unhealthy state and you want to make it more healthy?
Well, the first step is recognizing that you have a problem. So, we have delivered software before. We deliver software. We've had a couple of successful games. So therefore, whatever we're doing is exactly the right thing, right? It's like, well, good on you. You're not stinking the place up, right? That doesn't mean that it can't be better too, right? So I would say sometimes it's helpful to build a value stream map. If you don't know what that is, look up value stream mapping. It's not that complicated. Figure out what it is you're delivering that people value and then work backward. What are the steps it goes through to get there, all the way back to, customer requests or we have a genius in the back room. We slide pizzas under the door and he spits out brilliant ideas. I don't know what your process is. But trace it back and see what other steps, right? And on the steps, what really is the queue between the steps. Probably your steps aren't such a big deal. We had these guys, developers who were spending 2 days usually developing a ticket size feature, whatever that means. And that work was usually being delivered 2 months later.
Wow.
Well, why is it the 2-day job takes 2 months to go out? Well, because it took 3 weeks to get to them. And then when they finished it, it went into the queue to be reviewed. And then sometime the next week it was reviewed and went to a queue to be tested and a queue to be scanned and a queue to go. And there's load testing and performance testing and things. And eventually it got a big pile and it waited for somebody with rank to say, okay, we can release now.
Right. Yep.
Right. Took months. 2 days of work took months. Now, if you're at a high enough level of manager and you don't see the difference, you think that when you put something into development, the work starts. And when it goes live, that's when the work stopped. And you don't know that process is 7% efficient. And a value stream map will show you, fill in the queues. And if you really want to get bonus points, fill in the cycle times. So my developer has 7 jobs. They on average take 2 days. There's 14 days worth of work held up, right? And if I have multiple developers, why doesn't somebody else take the most important piece of work? Well, it's been assigned to that one.
Yeah.
Well, what if they work together to clear the work faster? How much are the returns? And then value stream maps don't have a reverse flow. Everything goes forward, right? Write down the pass rates for find out what it is. What's your pass rate? So if you find out that you've got, 300 things in progress, and your pipeline pass rate is 12%, I can tell you where your problem is. It's not your programmers. And making your programmers work faster is actually going to clog the queues even more. Your flow is going to be so poor that you'll actually make it worse. And if you put them on nights and weekends, it'll make it even that much worse. Yeah. What you might want to do is double the amount of time they get to work on it if it reduces the amount of time it spends in queues. And then follow up with maybe read critical chain, some gold rat stories about theory of constraints. Learn how to have a system generate flow. You will find there's some surprising things and your BS detector is going to go off like mad. Like when you find out that people waiting for work is better than work waiting on people.
Mm-hmm.
It'll blow your mind, and it doesn't sound right, and it doesn't feel right, and it tastes funny. But measure where you are is an important part of that. See what's going on and see if it isn't true, right? One of the things I tell all my students is that most people never taste their food. You probably don't either. I didn't for a long time. You taste it enough to recognize it. Yes, it's a Wendy's hamburger, and no, the mayonnaise hasn't spoiled, right?
Right. Yep. Yep.
So you recognize it. What did it really taste like? What do you mean? It tastes like a hamburger. What did it taste like? Was it how salty, how bitter, how herby, what did the bread taste like? What did what kind of cheese was it? How did the cheese taste? Was it fresh? Was it creamy? Was it, where was that? How was the beef really? Was it salty? Was it briny? Was it, what can you tell me about that? What about the onions? How did they taste? You don't taste them, right? Most people don't. They just recognize their food and put it down the hole. It
Right.
has a purpose. Yeah. But if you were to taste your food, you would probably find a whole world of things going on there that you weren't really aware of. I learned this because my wife opened a catering business once upon a time, and we had to do recipe development. And suddenly we were tasting our food. It's like this chicken salad. What is that taste? What's in there? And it's like, I don't know. It's kind of a dark note that I didn't expect, but it's kind of nice. Oh, that's fennel. There's fennel in there? Why did they put fennel in there? You start learning these things. Well, you should taste your day. Most people show up intending to fall into the pattern, complete the pattern successfully, do the thing they always do, right? You relax, engage the intuition, the autopilot goes on. Just like when you're driving to work, you don't really notice every stop sign and every tree on the way. You just go, right? You're not really participating. I would say, taste your life, taste your food, really participate for a little while. Pay attention. When you're coding, what made the wrong thing seem like the right thing? What made the right thing seem right? Why did you like this expression instead of that one? Why did you use this formatting instead of that formatting? Why did we do what we did the way we did it? Not saying that we shouldn't, but what was our criteria? Well, you should always do this. Should. Red flag. Bing. What's the basis of should? Does that mean like if we don't, that we'll become ill? Or if we don't, that we'll certainly fail in the marketplace? Is that a should because it would be easier for me if you did? What's the should? Little things. Pay attention. See what the actual process is. Feel what is uncomfortable and what's comfortable. Feel the holes in your knowledge, the things that I don't know that would make me more competent if I knew. If you're going to pursue learning, look for the things you can learn that fill the gap between what you do and the higher level of what you might possibly do had you known, right? Look for those things that raise you up. If we're happy with just follow the pattern, do what we always do. Oh, but it's 36% pass rate. Yeah, that's not so bad. People are worse than us. We're still delivering software.
Right.
We have bugs. Oh yeah, everybody hates interruptions, but that's just part of software. And taste your day. Where does that come from? Learn from it. The world isn't done teaching us yet. I've been in this I've been in software for most of my adult life, actually all of my adult life and some of my pre-adult life. I'm still learning stuff here. Still learning stuff.
Yeah.
You're not done.
That. I love that. So I'm going to poke you in an area where you don't have as much expertise, but I think based on your experience, I'm curious your answer. Because in game development, and I think probably in a lot of industries, there's a time to write fast, throwaway, prototypey stuff where, hey, this isn't going to go through our 10 gates. We're testing a rough idea. We're doing this, we're doing that, we're doing the other thing. I'm curious how, if you were helping an organization that was trying to find the line between when is it okay to have this be sort of rough and dirty and get us just a quick user experience versus like, hey, we probably need to be practicing these disciplines you're talking about. Because that's what the word that kept coming to my mind as you were talking was like, there's a discipline to this. There's a discipline, there's an experience element to it, but there's a discipline element to this that like, when you do the dishes, you have to do them every day. And that takes discipline. And if you don't exert that discipline, then you deal with the consequences of that lack. Is there anything that's been helpful for you on the engineering side to help determine like, now it's time to start, applying those good practices? Is it, well, I just do them all the time so that way it's solved? Or is it there? No, there's a place for cheap throwaway.
I have so many scratch files you don't even want to know. And that's just like normal programming. That's not even artware. I do it all the time. Yeah, there's absolutely plenty of room to go explore things. I think that not doing that is maybe unwise. I worked with a group. We did industrial machines. So I did the embedded software. Other people did the ladder logic and function block programming, for the PLCs. Other people did the mechanical sides. When I came in on one of the projects, the mechanical engineer had a bunch of broom handles stuck together with wing nuts and bolts on his desk. That was his first prototype. And he was manipulating it with his hands to try to see if he could build the thing. And he's trying with magnets on the end, and he tried with gum on the end, and he tried all kinds of things to move something from here to a precise place over there, and figure out how many joints do you need and how many actuators do you need, and trying to figure out, what the process is physically and what does the space it requires. And, to get all the requirements started, he was building out of broomsticks. You got to. I think you've got to. You want to understand well enough to commit, right? And that's true. Even in the middle of software, it's like, well, I think I could do this better. Let me bring this over on the side and take real data and scribble this thing to see if this potentially is going to perform better, or maybe be a more logical structure for it. And, so there's always art and science, art and engineering teams having to work on things. You've got to have that. And by the way, that's one of the other reasons to do micro commits. Commit the work the way it is, then go try something crazy, and then do get reset hard. That's good for you. If you're afraid of get reset hard, you probably just haven't tried it enough. You're afraid of it because it sounds scary. It's actually not. If you can go right back to where you were 10 minutes ago, what the heck? But especially for proof of concept. And I think that's maybe where AI will be really helpful, is we can start saying, hey, give me a page with this on it. I'm taking web pages for a minute, for web apps. Show me some, build a component like this and a component like that. No. Color it this way. Use these assets or images. Use this thing. Pop this over here. Can you illustrate walking using this kind of a thing? Okay, I'm going to try it this other way. No. Okay, now we know what we're shooting for. Let's use that as a model, and let's come over and work with some discipline. I probably don't want to just copy it and paste it as it is, unless first I go through the trouble of productizing. And that's what my engineer friends were teaching me is you have a proof of concept, first you have, these rough sketch throwaway models, the wooden sticks. Eventually you're going to get down to an erector set, and eventually you're going to get down to some machine, right? And you're going to make one that actually does work. But that's not productized yet. It's got to be hardened for the factory, and it's got to have all the safety requirements. So you decide at that point, this is where we're committing. This tire balance machine, from this point, we can commit to actually producing a real version of this. And, maybe that once we produce that version, we don't field it yet. Maybe we decide that was the wrong productization, but we have committed to building a proper one. So What does it take for you to be ready to commit? If you commit to begin with, then you might as well do everything with full discipline. But if you are deciding whether to commit, then you haven't committed yet. And, make it loose. Let artist teams go wild. Let engineers hack code, scribble up Python, stick together, give them broomsticks and wing nuts. Nothing wrong with that.
Yeah. I think the thing that's coming to mind for me as you're saying that is one, I think it's spot on. And I like how you took it into the world of the physical of like, look, this person was doing it with broomsticks. And one of the thoughts that came into my head is, well, obviously that can't go into production. But then you kind of walked through this broomsticks to erector set to actual machine, but still not hardened, safety approved, could sit in factory, expected to run without, regular maintenance for months at a time. Like there's levels to this. And I think in software, we have this trap because it's not concrete like that. It's not physical, that the prototype ends up in production.
Huh?
And we didn't do that. And so what, on a good day, it's the erector set. And on the bad day, it's the broomsticks.
Uh-huh.
And that's now underlying code that's going live because we're busy, because there's so many things to do, because, we come up with terms like tech debt and all this different stuff to talk about. Yeah, we know about that. And we're all just hoping a broomstick doesn't break, cause it's holding a lot of load right now. And inevitably it does, somewhere. And then we're all in panic mode for a while. And we patch it. We glue the broomstick back together and we put a bolt through it or something. But then we just leave it there. We still didn't fix it. And I think that's, I don't know if you have anything to say about that, but this is that one of the challenges for me, because I love it when teams do go prototype, try stuff, throw it at the wall, see what sticks, do all the, creative, narratives, doing like mood boards, engineers, designers just trying things and throwing it and hacking it really bad in scripting languages. And it's like, we would never ship this. What has been something that's help teams navigate that translation from, okay, we're now ready to commit. It's time to reset hard. It's time to get reset hard, and go do it right. And I actually, I'll take the blame for this too. At least my class of like the non-technical managers and the middle managers, the folks like myself, who just go, well, I can see it. It's working. Look, I can see it. I can play
it's
it.
done.
It's fine. It's done. This looks like, and they're like, well, I got to go do some work on that. I'm like, no. We got other stuff we got to do. Like, that's fine. Like, I won't just say, obviously this is a pure engineering problem, because I know that my class, my role in an organization is as or more responsible, I think, for a lot of these issues. But in the last few minutes, I'm curious what's coming up for you as I'm talking about this.
Well, you've got to first spot the load-bearing duct tape, right? So that's the big part. And if people are taught to be quiet about it, then they will be quiet about it. And there certainly is a ship then fix. That's a perfectly reasonable thing. But, you're not dealing with somebody hired you to put together a web page for them, and where the consequences are quite that small. Gamers, my son's a gamer. He gets pretty pissed off when he walks through a wall or floor and gets stuck.
Yeah.
It doesn't make him very happy. And he has quit games because they're just too, they're just a good idea that wasn't carried out well. But you're in a product, a product is a revenue stream. That's not the same thing as a project. So you have to think about your budgeting, your portfolio of budget. Part of that has to go to sustaining. Part of that has to go to expanding. You have to think about, well, I need to do some work that's going to make it easier for me to do more work. Right? And how can I make next week better than last week? Or how can I make next month better than last month? That's important, because that's taking care of the system of productivity. And then we have features, and then we have failure demand, right? And you can choose how to spend your money. Now, people will always push, don't fix the bugs, just get new features in, get new stuff. They just want new stuff. They don't just want new stuff. They would like for the problems to go away, but it's also really hard to take an update that is just bug fixes. It is. Right. I appreciate that. And they're not interested in a release that is just sustaining work. What do I get with this release? Well, the internals are structured better, and it has a better potential performance when we add the next 3 features.
We went from 99.98 to 99.99 on something.
Yes. Yeah. That's really hard to sell, and I appreciate that. But of course, a significant bug is always good to fix. But you need to think about your budget, right? So sustaining, advancing, correcting. How do you want to split that? And we have given that before, that as an actual measure to product managers. And they have together said, you know what? We're really close to time for people to renew their subscriptions. So we would like to see 60% go into corrections. And we would like to minimize the advancing. So mostly sustaining and some new features, but nothing that really is, sustaining and advancing the state of the art. And then later on, it's like, okay, the subscription time is up, but we're trying to get new users. So we need to put some whiz bang in there. We need to get some sizzle on this steak. So why don't we cut back on some of the sustaining practices, the corrective and the advancing practices, and push a bit more feature right now? And it's like, okay, this is traditionally our lull time. Let's really get the basics down. So let's put all of this into advancing, So you have to really think about what's the right time for your portfolio. And we actually did that, by the way, in self-organizing teams. So here's jump past 2025 for a second. You've got a pool of people, and we know that we've got 30 people, say, and management says, okay, I want 20, 10, and 5. Those are the proportions I want. And the people say, I've been writing new features long enough. I want to go on support. I want to go help because I've written the features. I want to make sure they get corrected correctly. That people understand them when they fail in production, when there's problems. And if there are, so I'm going to go on that team for a while. And other people are like, I've been doing both for a while. I want to go help improve our overall architecture and performance. And so we made the rule that everybody has, that there are permeable boundaries. You have to meet the numbers. So we can only have 20 people where it says 20, but we don't care who they are. And if you want to trade with somebody, as long as they're ready to trade with you, you can trade anytime you want. Totally permeable boundaries. And then flexible portfolio. And darned if that wasn't effective. And they developed patterns we didn't even think about. People were going from their architecture, and then it's like, okay, we did this so that this feature would be easier. Now let's go add this feature. Oh, the feature's done. Let's follow that into production.
Yep.
And then we'll go back and build another feature on the architecture we put in. And it's like, oh, this would have been easier if the architecture had been revised the other way. So they want to go join the architecture team. And these rotating casts means that everybody worked on everything. And the knowledge was high, the defects were down, and the seasonal nature of the business was controlled by the product managers. Not everybody can do that. I get it.
Right.
Or not many people know how to structure for that. But what a cool idea.
Yeah. By the way, just to speak to that, I've set up something similar in content creation teams where it's a very multidisciplinary structure and historically been more pipelines driven, like waterfall driven, like, okay, do this, then do this, then do this into this sequence. And I've actually, I've broken the flow of people moving through with the product, and it made an absolute mess. And then when we put it back in place where it was a flow of people moving with their product through the pipeline, it was amazing the difference in outcomes. Because to your point, people like following what they feel like they own, what they've emotionally invested in. It's an advantage of having your name associated with something. I want to see that go all the way through to the end, even if I'm only step 1 or step 2. And so I'm staying with it. And that means that when something does go wrong, we don't have the whole, I get tossed back something that I'm no longer even thinking about. I'm still right here. I've been following it. I'm aware. I have context. So anyway, okay, we're over time.
Yeah.
And I very much appreciate this conversation. Thank you a ton, Tim, for coming on and talking about engineering and best practices. And I hope sincerely that games start taking things like this more seriously. Where would you like to send people to? We had a couple of things that we'll make sure we get into the show notes, but what else, anything else you want to send people to so they can learn more about this and understand how they might become better at engineering and reset their BS detectors a little bit?
Yeah. So, of course, right now I'm working with Industrial Logic. I've got the shirt on. You can see the little badge. And of course, I'm happy to answer any questions. I'm very easy to find on social media. A lot of good articles on the Industrial Logic blog I could recommend. Of course, Dave Farley and Emily Beisch and that group have a continuous delivery. We're huge in continuous delivery. And the things they do to make it possible to deliver continuously are the same kind of things you can do to make it easier and safer to deliver even periodically. I don't suppose you're releasing mobile games every day. You would lose a lot of people that way. But probably every 2 weeks or so, maybe. Those are places to go. If you want to follow me, I'm agileotter.blogspot.com, and I'm on, like I said, every social media you can point at. Find me on LinkedIn, follow me, ask me questions. I'm also, if you're on the RAND's leadership Slack, which I guess 40,000 people are now, can find me there as well. And if that doesn't work, there's always email, and I don't mind having T Ottinger, Tottinge @gmail. I answer email questions as often as I can. Don't expect to have same hour, but somewhere in that today's load of 500 emails, I'll try to find yours and answer your questions for you.
Perfect. All right. We'll make sure to have all that down in the show notes. Tim, thank you so much. It's been a great conversation.
It's been a lot of fun, Benjamin. Thank you so much for having me on.
Yeah. Cheers. All right. Bye-bye. All right. Let's summarize that episode. So first, not every engineer has the same experiences. Some are stuck in old practice, passed on by the organization and engineers they've been surrounded by. When you try to talk about modern best practices with someone who's only experienced and is stuck in decades-old process, it feels alien and probably fraudulent. I think this occurs frequently across many disciplines in game dev, where we have this idea that if you haven't been doing game dev a long time, you just don't know how to get it done, and nothing you could say could add value. We know what we're doing. Second, regular releases with less stuff are safer and less disruptive to your team, and in our modern world, it is also technically feasible. You don't have to be spending weeks or months on every release. Third, because everyone is constrained to their own experience when it comes to what they see as feasible or not. Sometimes the worst experiences of their past, like a bad group project in college, like Tim mentioned, become their baseline for thinking about what it means to collaborate with others. Telling them collaboration is the way to succeed feels absurd to them. Fourth, every time work loops back within a system, it incurs a context-switching cost. The more loops you have, the more checks, the more opportunities for that to occur. The longer it takes for someone to notice and send the work back to the start, the higher the cost. As much as possible, you want to build systems that spot problems as close to immediately as you can. Fifth, crunch isn't just not adding value, it may also be harming you and your team. By asking engineers to work an extra several hours a day, the measured cost due to lower quality far exceeded the additional hours put in, according to one study. Sixth, sustainable development and simple small releases may work really well and increase your chances of succeeding, but they are far less emotionally gratifying than grand reveals and giant spikes of effort that you can be proud of and talk about later. It's good to keep this in mind. Seventh, programming is not pure logic and math performed by an engineer with every variable clearly understood. It is much more about pattern recognition and attempting things to see what works. There is art and science involved, not simple execution. Eighth, build a value stream map for your system. What you may discover is that time spent working is often a very small amount of the total end-to-end time of getting something done. It can be worthwhile to understand why and see if you can improve your system and shorten your cycle times. Ninth, taste your day. Don't just go to work or your office if you're remote and fall into the same pattern over and over. Take a minute, considering what your day consists of, where problems lie and what could be better. Look out for unjustified shoulds that are everywhere. Note where you fall into simple routines that may not be helping you. All right, those are the big ones for me. Thanks a lot. Bye-bye.